All right, guys, let's go ahead and get started. Go ahead and start on this proof if you'd like. We'll be going through it in just a few minutes. All right, so getting started, we know that BC is congruent to CD. We know that CG is congruent to CF, and we know that angle AGB is congruent to angle EFD. What we want to prove is segment AG over here is congruent to segment FE. So to get started, we have all of our given information on here. So BC is congruent to DC, CG is congruent to CF, and angle AGB is congruent to angle DFE. So next thing that we're going to go ahead and do in this proof is say that these two angles are congruent, angle BCG and angle FCD. And the reason that we can say that these two angles are congruent is because they're vertical angles, and we know that all vertical angles are congruent. Now, at this point, we can go ahead and prove that these two smaller triangles are congruent, triangle BCG and along with that, triangle DCF. And the reason that we can say that these two triangles are congruent, BCG is congruent to triangle DCF, is because we have side, angle, side. So those two triangles are congruent by side, angle, side. Now, from here, again, our goal is to prove that AG and FE are congruent. So at this point, I'm going to go ahead and take pieces of these smaller triangles that we just proved are congruent to prove that the larger triangles are congruent. So at this point, I'm going to go ahead and say that angle BGC is congruent to angle CFD. And the reason I can say that is because after triangle congruency comes CPCTC. Now at this point, I should be able to combine these two angles together, these two green angles. So to do that, I'd say angle AGC, the full angle, is congruent to angle CFE, also the full angle, because I'm just adding these two angles together. So that'd be by the addition property. Now at this point, we should have enough information to prove that the larger triangles are now congruent. And if I look at this, there's a couple different reasons why. Well, actually, there's just one specific one. We have angle, side, angle. Now you may be wondering, can I use side, angle, side here? Well, no, because BC isn't a side of the larger triangle. It's a side of the smaller triangle, but not of the larger triangle. So I can't use side, angle, side here. I must use angle, side, angle. So triangle CGA is congruent to triangle CFE by angle, side, angle. Well, now if the larger triangles are congruent, we should be able to say that AG is congruent to FE by CPCTC. Because after triangle congruency, I can say that the corresponding parts of those congruent triangles are congruent. All right, next up, today we are going to be talking about 3.9 detour proofs. Now, the proof that we just did was a detour proof. We went ahead and we took a detour in there to prove two other triangles were congruent. So that's what we're going to be doing today. Detour proofs are when we must prove more than one pair of triangles are congruent to solve a problem. Just like we did in our warm-up. We had to prove the smaller triangles were congruent, and then we used that information from the smaller triangles to prove the larger triangles were congruent. So that's what these detour proofs will be all about. So here's our first one. AB is congruent to AD, BC is congruent to CD. We want to prove that triangle ABE, the smaller triangle, is congruent to triangle ADE, this other smaller triangle. So to get started, we go ahead and we write our givens, and we can draw it up on the actual picture. Now, what they gave us is two legs, right? They gave us two legs of triangles, which that should help us out quite a bit. So the next thing I'm going to do is I'm just going to prove the giant triangles are congruent, the biggest triangles that we have in this picture. So I'm going to say that AC is congruent to itself, and that's by the reflexive property. Now, if I look at these two larger triangles, we have side, side, side. Well, that's enough information for us to show that these two triangles, the large triangles here, ACB and ACD, that those two triangles are congruent. And they are congruent by side, 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 as we said. Now again, our goal is to prove that the smaller triangles are congruent. That's what we want to work towards. So in the bigger triangles, we're looking for something that they share with the smaller triangles. So I already have this side length AB. Now let's use this angle here. So I can say angle BAE is congruent to angle DAE. The reason for that is because if the triangles are congruent, then the corresponding parts are congruent. And again, I chose these angles here because they are shared by the big triangles, which we just proved are congruent, as well as the smaller triangles, which that is our end goal here, is to prove the smaller triangles are congruent. So I'm looking for things that they share. So the reason I can say these angles are congruent, again, is by CPCTC. Now at this point, is there anything that's shared by the two smaller triangles? Well, yes, they both share segment AE. So I can say AE is congruent to itself by the reflexive property. Now we should have enough information to prove that the two smaller triangles are congruent. If I look at them, we have side, angle, side. So therefore I can say triangle ABE is congruent to triangle ADE. That is our end goal. And the reason that we can say that is because we have side, angle, side. And with that, this proof is complete. All right, next up. From here, we're just going to go ahead and do some practice. So, find the coordinates of the midpoint of each side of triangle ABC. Now, if you don't recall, we have the midpoint formula right down here. It's just we're going to take the average of our x values, and then we're going to take the average of our y values. And our answer will be written as a point. So for segment AB, we go ahead and we write this out as x1 plus x2, or 6 plus negative 4, over 2. And then we have y1 plus y2 divided by 2. So 5 plus 3 divided by 2. Well, that'll give me 2 over 2, which is 1, and 8 over 2, which is 4. So my midpoint is at 1, 4. As for AC, again, we're going to do the same thing. x1 plus x2 divided by 2, y1 plus y2 divided by 2. If we look at this, we have 6 plus negative 4, which will give us 2, divided by 2 is 1. Then we also have negative 1 plus 3, which is again 2, divided by 2, which is 1. So our next midpoint is at 1, 1. Lastly, for BC, again, we have our 2 points, so we'd have 6 plus 6 over 2, and 5 plus negative 1 over 2. Well, 6 plus 6 over 2 is just 12 over 2, which will give us 6. And then 5 plus negative 1 over 2 is 4 over 2. Well, 4 divided by 2 will just give us 2. So our last midpoint is the point 6, 2. And those are the midpoints of each side of triangle ABC. And if we look at this, it seems like it could be an isosceles triangle. Do we know for sure? Well, we could find out, and in fact, we'd find out that it's not, just because this is slightly higher than this midpoint. All right. Next, find the coordinates of the point where the median from A intersects segment BC. So if it's a median, I know that's intersecting at the midpoint. So I need to find the midpoint of BC. So to do that, we do the same thing. I do x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Well, that gives me 2 plus 12, which is 14, divided by 2 is 7. That gives me 1 plus 3, which is 4, divided by 2, which is 2. So my midpoint is 7, 2, and that would be the point where we intersect, because again, it's crossing through the median. All right, a circle with center at O has the diameter shown. Find the coordinates of O. Well, if it's a diameter, I know that's going through the center, and it's just double the radius. So I need to go ahead and I just need to find the midpoint of my diameter. Because if I find the midpoint of my diameter, that will be the center of the circle. So again, we're going to find the midpoint. So we have 8 plus 6 divided by 2. Well, 8 plus 6 is 14, divided by 2 is 7. And then for our y value, 10 plus 2 is 12, divided by 2 is 6. So the center of the circle is at 7, 6. All right, here is another proof for us. Given circle O, and we know that angle B is congruent to angle C, we want to prove that AO bisects segment BC. So we want to show that these two segments are congruent. So to get started, we write out our given circle O and angle B is congruent to angle C. That is given information. Now, if we know that we have a circle, well, first off, if I have two base angles that are congruent, I should be able to say if my base angles are congruent, then our legs are congruent. So I can say that AB is congruent to AC. And again, that is just by knowing that if base angles are congruent, then legs are congruent. From here, we know that we have two segments that we can draw to make an auxiliary line, and this is going to make larger circles for us. So I draw segments BO and OC. Now, the reason that we can do that is between any 2 points is a segment. So we can create a segment, a line, or a ray through any 2 points. From here, I can say that OB is congruent to OC because we know that all radii in a circle are congruent. And if all radii in a circle are congruent, then OB and OC should be the same. Now, at this point, I should be able to say that AO is congruent to itself, and that would, of course, be by the reflexive property. Anytime that something's congruent to itself, it'll always be by the reflexive property. And with that information, we should now be able to prove that the 2 large triangles here are congruent to each other. So triangle ABO is congruent to triangle ACO, and the reason that we can do that is side, side, side. So 3 sides of a triangle are all congruent, which allows us to say that those triangles are congruent by side, side, side. From there, again, our goal is to show that AO is bisecting segment BC. So I'm going to go ahead and start focusing on the smaller triangles now. So I can say that angle BAE is congruent to angle CAE, because if triangles are congruent, then corresponding parts of congruent triangles are also congruent. So again, triangles are congruent, which allows us to use CPCTC. Now at this point, we can show that these 2 triangles are congruent, the smaller ones up top, because we have angle, side, angle. So therefore, triangle BAE is congruent to triangle CAE by angle, side, angle. Well, if those 2 triangles are congruent, then I should be able to say that BE is congruent to EC. And the reason that I can say BE is congruent to EC is because if triangles are congruent, then corresponding parts of congruent triangles are congruent as well. And with that, we now can say that segment AO bisects segment BC, because we can see that BC is being cut perfectly in half because it's congruent on either side. So therefore, if a segment divides a segment into 2 congruent segments, then it is bisected. That's the definition of a segment bisector. All right. Next, WX is congruent to WZ. XY is congruent to ZY. We want to prove that triangle XAY is congruent to triangle ZAY. So to get started, we have our given information. I'm just going to go ahead and put it all up right now. WX is congruent to WZ, and XY is congruent to ZY. From there, I can say that YW is congruent to itself by the reflexive property. Well, that will allow me to say that this whole triangle WXY is congruent to triangle WZY. The reason that we can say that is side, side, side. From there, I should be able to say that these 2 angles are congruent, angle XYW and angle ZYW, because if the triangles are congruent, then the corresponding parts of those congruent triangles are congruent. From there, since I'm focusing on the smaller triangles now, these 2, I can say that AY is congruent to itself. Again, I'm just taking the part that is on those triangles. AY is congruent to itself by the reflexive property, which will then allow me to say that triangle XAY is congruent to triangle ZAY by side, angle, side. And that proof is now complete. All right. Next, MN is congruent to NS, and MP is congruent to PS. We want to prove that angle MQP is congruent to angle SQP. So to get started, we're going to go ahead and write out our givens, and we can already see that we have 2 sides. So let's go ahead and prove that the 2 triangles, triangle PMN and triangle PSN, are congruent. To do that, we just need one more side, such as PN. So we can say PN is congruent to itself by the reflexive property. From there, those 2 triangles are congruent by side, side, side. So triangle MNP is congruent to triangle SNP by side, side, side. And now we have these 2 triangles that are congruent. Now let's focus on these 2 smaller triangles. So now I can say that angle MPQ is congruent to angle SPQ. And the reason that we can say that those 2 angles are congruent is because after triangle congruency comes corresponding parts of congruent triangles are congruent. From here, I have a side and an angle. I can see that both of these triangles share side length PQ. So I can say PQ is congruent to itself by the reflexive property. Now lastly, if that is true, then I should be able to say that these 2 triangles are now congruent. And it's not lastly, we still have one more step after this. These 2 triangles are congruent, triangle MPQ and triangle SPQ, by side, angle, side. So triangle PMQ is congruent to triangle PSQ by side, angle, side. And if those two triangles are congruent, these two smaller triangles, then I should now be able to say that angle MQP, our goal, is congruent to angle SQP, also our goal. And we can say that because if the triangles are congruent, then the corresponding parts of congruent triangles are congruent. All right. This should be our last one for the day. Given that A is equidistant from B and D, meaning that AB is equal to AD, we want to prove that AC bisects angle BAD. So, to get started, we have our given information. And if something is being bisected, then I should be able to say that's being split in two. So I should be able to say that angle BAE is congruent to angle DAE. Now, I went ahead and I put the given information, the equidistant, I went ahead and put that as AD is equal to AB, because that's what it means to be equidistant. And if two things are equal in measurement, then they are congruent to each other. So here's all the information for that. If 2 points are equidistant, then they have the same length. If two segments have the same measure, then they are congruent. From here, now we can say that those two angles are congruent, angle BAE and angle DAE, and those two angles are congruent because the definition of an angle bisector. If a ray bisects an angle, then the angle is split into two. From here, I can say that AE is congruent to itself. And the reason that we can say that is the reflexive property. Now we have enough information to say that triangle ABE is congruent to triangle ADE. And the reason that we can say that is side, angle, side. Lastly, at this point, if the two triangles are congruent, then I can say that BE is congruent to ED. And the reason that we can say that is CPCTC. Now, if segment BD is being split into two congruent segments, then it is being bisected. So therefore, I can say that AC bisects segment BD. And the reason that we can say that is if a segment splits another into two equal pieces, then it is being bisected. All right, so that will be it for today's notes. If you guys have any questions or need anything on it, please let me know. Thank you guys so much for watching and have a great rest of your day. Take care. All right, here's our final proof. We're given that PR is congruent to PU, QR is congruent to QU, and RS is congruent to UT. So just get started. I'm just going to go ahead and write out all of our given information and draw it on the picture. And it's just going to be all in one statement. So this is what we have so far. So again, RQ, the full thing, is congruent to QU, the full thing. RS and TU are congruent, and then RP and PU are congruent. So to get started on this, the first thing I'm going to do is I'm going to make this into two large congruent triangles. And to do that, I need to draw a new segment. So I'm going to go ahead and draw segment PQ. So it's going to go straight from P down to Q. And the reason that we can do this is between any 2 points is a line, ray, or segment. So I'm just going to put any 2 points to determine a line. Now, with this new line that we just drew, well, it is shared by both large triangles. So I can go ahead and say that PQ is congruent to PQ. And the reason that we can say this is the reflexive property. Anytime that something is congruent to itself, it's always by the reflexive property. Now, at this point, we should be able to prove that these two large triangles are congruent. And just reading the congruency signs, we have side, so the blue side, the red side, and the purple side. So therefore, triangle PQR is congruent to triangle PQU by side, side, side. So again, that's because we have three congruent sides here, the blue, the red, and the purple. So side, side, side. Now, if that's the case, we're now going to look for things that are shared by both the large triangle and the small triangle. So looking at these, both triangles share segment PR, but we already know that those are congruent from our given information, PR and PU. They also share angle R and angle U. So therefore, I can say angle R is congruent to angle U because after triangle congruency, after we prove two triangles are congruent, what comes next is always going to be CPCTC. So corresponding parts of congruent triangles are congruent. Now, if these angles are congruent to each other, we should now have enough information to prove the two smaller triangles, triangle PRS and triangle PUT, are congruent as well. So we can go ahead and say that triangle PRS is congruent to triangle PUT. And the reason that we can say that is blue side, the angle that we just found and then the green side. So side, angle, side. So triangle PRS is congruent to triangle PUT by side, angle, side. Now, if these two triangles on either side are congruent, well, looking at it, angle 1 and angle 2 are pieces of that triangle. So I can say angle 1 is congruent to angle 2, what we're trying to prove. And the reason that we can say that is because if triangles are congruent, then what comes next? Well, after triangle congruency comes CPCTC. So after triangle congruency, again, comes CPCTC. All right, that is it for our proof. Thank you guys so much for watching today. I really do appreciate it. If you guys have any questions, please let me know. But other than that, have a great rest of your day. Thank you guys for watching, and take care.